Okay, after that brief intermission of a glitch, let's try one more time.
No one else will know about it but us.
Appears to be working. Insert for your viewing pleasure. Or for as if rotor. Anyways, Virginia, I hope you enjoyed that brief intermission. Anyways, dy dx equals 2x minus y. So I need to find the slope at each of these points on this graph that were given to me, like we did in number 30. But this one's going to require a table because it's not just like plugging in a y value and seeing what happens. This is now multiple things.
X and Y values.
So I do x. Okay. Y.
Oh.
And I do 2x minus y. And I'm going to basically do it at each of these points. So what I usually do is I'll stick with all the x values, so all the x's of -1. I'm going to do 2 in each block since my blocks are big.
My blocks aren't blocking.
Clearly mine were earlier. And then I'm going to choose each of the y values, so -1, 0, that was a weird 0, 1, and 2.
Is it still weird?
No, I fixed it.
Oh, man.
And then I'm just going to block them off a little bit so it's easier to see. And then at 0 for the x's, from -1, 0, 1, and 2. Oh man, I didn't make it big enough. And then at 1,
I didn't make it big enough either.
started to glitch again. This is not good. Okay.
Might not be good, but it sure is entertaining.
True. And as we do this problem, you're going to understand why we appreciate this slope field is as small as it is.
Of course.
Because if it was bigger, then I would be doing a much bigger table than this. So
yeah,
basically,
I appreciate its lack of size.
Basically, I'm just plugging these values in. So 2 times -1 is -2, plus 1 is -1. I have to very intently think about this. This is -2, -3, -4. Then when x is 0 and y is each of these numbers, when x is 0, it's just whatever basically the number is, but negative or opposite. So this would be +1, this one would still be 0, this would be -1, and this would be -2. And then down here, 2 plus 1 is 3, 2 minus 1 is 1, 2 minus 2 is 0. Okay. Is that what you got? Or are you just trusting my math?
Oh, I kind of went ahead to see if my math matched up with yours. I do that sometimes.
All right, so now I take at each of these points, so at -1, -1, I have a slope of -1. -1, 0, I've got a slope of -2, so it gets a little steeper. Then I've got a slope of -3, a little steeper.
Oh,
And then
goodness, that's not the right spot.
-4, even more steep.
One moment.
Holding. For my values of 0, or when x is 0.
I guess it's not too hard to figure out how steep to make them, because like
Just progressively make them a little bit more.
you just have like one spot that's like, I guess your point that you aim it at.
Yeah, pretty much.
My spot was 0, -2 that I was aiming them all at.
Pretty much down here. All right, this one, 0, -1 is a slope of 1. 0, 0 is a slope of 0. 0, 1 is a slope of -1. And 0, 2 is a slope of -2.
All of those I was aiming it at 1, 0.
Let's see. At 1, -1, I'm at 3. At 1, 0, I'm at 2. At 1, 1, I'm at 1. And at 1, 2, I am 0. And you've successfully done a slope field.
You know, I find it fascinating that like, all of them are, like, pointing to, like, the same, like, one common point.
Yeah.
Like,
Well,
for
it'll
each
be because
x.
obviously we're not seeing the whole thing, but it'll be what graphs, and it could be a graph that goes down. There's all different things that
Like,
it can
for
do
each-
for you.
For each x value, they're all, like, all of those things are pointing at the same common point.
True. All right. That's the baseline of a slope field. You won't have to do one bigger than that on the quiz or the test. Now, I will probably just tell you, like, on there, do it like we did in class. It'll say, like, from on the x -1 to 1, on the y -1 to 2. It'll just say something like that, and you'll just need to, like, set up the graph. Like, it's not going to be given to you, but it'll be just like these ones. All right, the next stuff in this section, Euler's method.
Wait, who?
Euler.
I thought last time you called him Euler.
You did. I called him Euler.
No, I called him Evler.
Then Virginia did. Somebody called him that, but it's not. It's Euler.
E-U-L-E-R. Not O-I-L-E-R.
All right, so
What if Virginia didn't call it that?
this is the clever application of local linearity to graph a solution without knowing the equation.
I love how I'm just, like, ignoring the lines while I'm writing this.
Same, clearly.
You're doing a lot better than me. My second line there is, like, written with, like, a line going through it. So, yeah.
Fair enough.
At least
All right.
I'm
What?
acknowledging it on my last line.
True. All right, so these steps are also on page 329, but I'm going to write them out for the most part, maybe worded slightly differently as far as this goes, and then we'll move into our last two problems using this stuff. So,
I have a question. Why do you have 3 tennis rackets? Not that there's anything wrong with it, but
that racket right there is like a racket that the school had. It's actually like a kid's racket. I got it out in case somebody like didn't have one and we didn't have enough, so that somebody would just have one to use for the time being. But I don't really want anybody using that one because it's like a kid's racket. It's like a junior racket.
are those, like, smaller, shorter?
Or shorter. Like significantly shorter.
I don't know. Do you think Brooke could have used one?
I mean, maybe, but these are like for like a kid like under 12.
Same height.
All right, so we begin
There's 1.
at the point xy specified by the initial condition.
next line just for one word.
2. Use the differential equation. What in the... My hand was literally down here the whole time.
Why is it built like that?
Use the differential...
What happened to the D?
It's glitching. Use the differential equation to find the slope. We're struggling again. dy dx at the point. Increase x, this is step 3, by small amount delta x. Increase y by small amount. I'm gonna guess.
Delta Y.
Yep. Delta y, where delta y equals dy dx delta x, which defines a new point x plus delta x, y plus delta y, that lies on the linearization. For using this new point, return to step 2.
Oh. How dare you?
Repeating this process constructs the graph to the right of the initial point.
I think you missed the T in right.
Stupid thing.
So how do we get to step 5? We have to go all the way back to step 2.
Like
then
you
we
keep
get step
doing it
4.
over and over again until you get to the end.
There is none.
To the right of the initial point given. Okay. Five. To construct a graph moving left from the initial point repeat the process using negative values for delta x.
What if we stopped calling it delta and just call it triangle?
People might get a little confused. And on that note, we are on to number 54.
Number who?
54?
Well, that's a big jump.
It's because all the other things in there are slope fields that you don't want to do. There's a slope field for the square root of y squared minus 4y plus 5.
Can you repeat that, please?
Square root of y squared minus 4y plus 5.
Okay, square root of all of that. Okay.
All right, so
First time I was thinking that it was square root of y squared, and then all that other stuff. I was like, it's like why?
literally. All right, so this is basically the instructions. I'm just writing it out so that we know exactly what's happening because it can get a little confusing.
Do I need my calculator for this?
I seriously hope not.
It's gonna be right there.
You might on number 56, but on number 54 you should not. 54. dy dx equals 2x minus y. Y equals 0 when x equals 1. And we know from the initial question, delta x is 0.1, x is 1.3. All right, so I make a table. It's the easiest way to do it in my personal opinion.
Yeah, just like make a table. What are we making it out of? That's an interesting expression you've got there.
Because look what it did.
Oh. How did it manage to do that?
I don't know. It was in the middle of drawing a line and it just highlighted out. Stop that.
The annoyed whisper.
It's making me angry.
Well, that was a nice line.
Thanks.
See, sometimes it likes you.
Oh my God.
Why is it broken up like that?
I don't know. What the? Bro, it's like you clearly need some help drawing a line. You stop glitching, I wouldn't have this problem.
Why does it actually look kind of crooked though?
I don't know. Okay. Hey, buddy, you missed it.
Oh. Has a little like nub at the end.
Bye-bye, ruler. Go away. No, I said bye. Leave. We're gonna fight. Okay, on that note.
I might have to go this.
All right, so I start at 1. So when x is 1, y is 0. Now, dy dx is 2 times x minus y.
That's 2.
That would be 2.
How many of these are we doing? Like, how many lines do I need for this?
3.
Okay.
Now, delta x is always 0.1, so I can put 0.1 in all of those already. Now this part here is this column times this column. Boom, boom. So what's 2 times 0.1?
0.2.
0.2. Beautiful. So now, this point is x plus delta x, so 1 plus 0.1 is 1.1, comma, y plus delta y is 0 plus 0.2 is 0.2. Now,
Almost opened my water bottle and dropped it.
this point, that would have been bad. This point transfers here. 1.1, comma, 0.2.
Oh, that was I meant to draw a comma, but instead it goes in parentheses.
So now 2 times 1.1 is what?
2.2.
Minus 0.2 is?
2.
Now, they won't always work out this way. Or it's the same number. This one just happens to be working out that way. So now, 2 times 0.1 is 0.2. So this value over here is 1.2, comma, 0.4. And we copy it down again, 1.2, comma, 0.4. Plug that in, 1.2 times 2 would be 2.4, minus 0.4 is just 2.
Yeah, I feel like this will only work for linear ones.
This process,
Like it'll only end up being the same for
well, we're showing that this is for linearity. But they don't always come out to be the same number either.
Huh.
Like the next one we're going to do isn't going to work out that way. So this is still 0.2.
I feel like Virginia's going to laugh when she hears whatever I just said.
It only makes sense for linear, like, duh.
Yeah, I forgot that it was only linear.
Just kidding. It's okay, sometimes I do too. And so now we have 1.2 plus 0.1 is 1.3, which is where I was trying to get to. And add 0.2, we get 0.6. So our answer for what we were trying to find is f of 1.3 is equal to 0.6. So all that work to get to this lovely answer here. Oh, we got time. All right, 56. Similar thing, but they're giving us different numbers to work with. This time, I'm just going to write it in the problem itself. So 56 is dy dx equals 1 plus y. It's linear. And y equals 0 when x equals 2. And then they told us in the initial like problem statement that delta x is minus 0.1 and x is 1.7. So I'm looking for essentially f of 1.7. This is the one where we might need a calculator because the numbers are a little weird. They're not as pretty as these numbers were.
Yeah.
Lord, here we go. Try again. And this one's still going to be 3 rows plus the top title, so 4 total.
Same things on the top.
Well, sort of.
Well, I mean different.
Minus that the problem is different.
Different things,
Oh my
but
gosh.
basically the same stuff except for the dy dx one.
Yes.
Gotcha. On the other one, I had the one with like delta y. I had 2 mini equal signs for some reason
That's always fun.
in the shape of an equal sign.
Bro.
It just teleported. The aggressive scroll. I'm sure that'll come through in the video.
If it doesn't glitch in the video and it just like all you hear is my voice and it's not actually glitching, it's going to be so embarrassing. I'm suspicious there's an update that needs to be run. Okay, so our first point is 2, 0. So when I plug in zero, I was glitching for a second, I get 1. Delta x is the same all the way down, minus 0.1, so I can add that in already. Delta y is the first thing here times that, so this is going to be negative 0.1. So that means that this is 2 minus 0.1 is 1.9. And then y plus delta y is just negative 0.1. Copy that down.
Right.
Plug it in. I'm going to get 0.9. Then over here, oh gosh, what is that? 0.09 negative. So then this is 1.8, and this is
0.19.
Yes.
0.19.
I was glitching again.
You were about to calculate that one.
I was, because I wasn't looking at the negative 0.1. I was looking at this number and I was like, huh? Then I was like, oh wait. Just having a glitching moment. Okay.
I get it.
So then 1 plus that, nope, minus that is 0.81. So then this is negative 0.081. So then this is 1.7 and negative 0.271. So then our answer is f of 1.7 is equal to negative 0.271. And we did it. All right, now you get to do a little bit more fun in the way that we do homework this section, because I get to, you pick what homework you want to do. Josh is like, I don't like this. I want her to pick for me.
Yes, please.
You need to pick from 1 through 9, 2 odd ones. From 11 through 20, 2 odd ones. And then 21, 31, 53, and 55. And we'll be doing 7.2 tomorrow.